So welcome to my new lecture of network theory. So in the first lecture I am going to teach you the introduction to circuit elements, okay? The basic of electrical circuit. Introduction to circuit elements. Now, what do you mean by circuit elements? Is it only resistance, capacitance and inductance? No. There are various types of circuit elements. First, you have to learn the types of circuit elements. So write down classification of electrical elements. Okay, so number one, linear and non-linear elements. Now type 2, write down active and passive element. Number 3, unilateral and bilateral elements. Number 4, time variant and time invariant element. And also one kind of element is lumped and distributive element. So linear, non-linear, active, passive, unilateral, bilateral, time variant, time invariant elements, and lumped and distributive elements. So in order to begin with the network theory, you need to learn all these classifications. Okay, and I will start with linear, non-linear. So number one, linear and non-linear elements. Okay, I think you all have idea about straight line. See, there are two equations, y equals to mx and y equals to mx plus c. Do you know the difference between these two plots? Okay. Suppose I am saying that the equation satisfies for all values of x. Okay, for all values of x. This is also for all values of x. That means it is continuous. Now y equals to mx means this graph will go through the origin, which means 0 comma 0. Okay, but here it is plus c. It means we are adding plus c amount with all the points of this line. That means this line will be shifted by some value c. So this graph will not go through the origin, but whereas the slope of these two equations will be same. But just see that the graph is not passing through the origin. What will be the distance from origin? This will be c, because all the points are shifted by c, right? Now write down the conditions for an element to be linear. Okay, conditions of linearity. So this is the first condition. It should follow only one equation of straight line. Condition number 2, it should pass through the origin. Okay, so the condition 1 is it should follow only one equation of straight line. Underline this, only one equation of straight line. And condition 2 is it should pass through the origin. Okay, and condition 3, for all time. Okay, so for all time means continuous, just like I mentioned that this equation satisfied for all values of x, for all values of x. So the condition 1 is it should follow only one equation straight line. Condition 2, it should pass through the origin. And condition 3 is for all time, that should be continuous. So here I have taken 3 examples, the VI characteristics, this and this. Okay, so in the first example, see, the graph is following only one equation of straight line. Only one straight line is here. So condition 1 is satisfied. Now condition 2, it should pass through the origin. Okay, yes, it is passing through origin. And for all time, it means if you extend this curve, it's continuous. For all values of v and I, it is continuous, right? So it is a VI characteristics of a linear element. Now in the second example, see, again it is following only one equation of straight line, right? And it is passing through origin. So condition 1 and condition 2 is satisfied. And condition 3 also, if you extend this, you can extend it up to infinity. So for all time, continuous. So again it is linear. Again it is linear. See in the third example, okay, it is not following any equation of straight line. So no need to check the other two conditions. Okay, from the first condition only we can say it is non-linear. Why non-linear? Because it is not following any equation of straight line. It is curved like this. It is not a straight line, so it is non-linear. Four examples I have taken here. Okay, so in this first example, see, the straight line is passing through origin, and this is following only one equation of straight line, but not for all time, because there is snow plot in the negative side. It is only increasing to the positive side, so we cannot say that it is satisfying the equation for all values of I, which means it is not continuous. So it is following only one equation of straight line passing through origin, but not for all time. That is why it is again non-linear. So what do we understand? That as our element should satisfy all three conditions in order to be a linear element. Otherwise it will be non-linear. If it violates any one of the condition, then it will be non-linear. Now see in the second example. This is not following any equation of straight line. So clearly we can say that this is non-linear. No need to check the other two conditions. It is already non-linear. Because why? Because it is not following any equation of straight line. It's a curved line. Next, the third example, this one is very important. See, the condition 1, it should follow only one equation of straight line. Yes, it is following only one equation of straight line. It is passing through origin, so condition 1 and condition 2 is satisfied, but it should follow the equation of straight line for all time. See, after reaching this point, this curve is saturated. Okay, so it is not following the equation of straight line for all time. So again it is non-linear, because condition 1 and condition 2 is satisfied, but condition 2 is violated. So this is non-linear. Why? Because condition 3 is not satisfied. See in this example. Again, it is following only one equation of straight line. It is okay. You see, it is passing through origin. Again, it is okay. But not for all time, because there is no value in the positive side, positive value of current. So therefore, again it is non-linear. See in this case also, it is following only one equation of straight line. So condition 1 is satisfied. It is passing through origin. Condition 2 is satisfied, but for not all time, because after reaching this value, this curve is saturated. So it is again non-linear element. Non-linear. Clear or not? And in this sixth example, the straight line is following only one equation, passing through origin, and for all time. So it is linear. It is linear. Okay. In the upper example, see the VI characteristics y, where the straight line is following only one equation for all time. So condition 1 and condition 3 is satisfied, but it is not passing through origin. It is passing from this point. So condition 2 is violated. So again it is non-linear. Non-linear. Clear? So by analyzing the VI characteristics of any element, you can determine whether the element is linear or non-linear. You just tell me one thing. What is the Ohm's law? Ohm's law is V equals to IR. V equals to IR, right? It is exactly like Y equals to mx, right? Where V is y-axis, I is x-axis, and this R is acting as the slope. Okay. If y equals to mx is like this, then this should be also applicable for V equals to IR, which means x-axis is I, y-axis is V. Now you tell me, this curve is following only one equation of straight line, passing through origin, and for all time. So you tell me whether resistance, which means R, is linear or non-linear. Yes, it is linear. Linear. Clear?